In this video, I'm going to be showing you how to solve exponential equations using inverse properties. When the bases are the same, you actually can set the exponents equal to each other. So since you have 3 raised to the 4x and 3 raised to the 5x minus 11, then you automatically can set the exponents equal to each other and solve. You would subtract 5x from both sides and get negative x, divide by negative 1, and you would get a positive 11. And just to prove that does work, if you plug 11 back in, you will get 3 to the 44, and 5 times 11 is 55, minus 11 is also 44. And so those two functions or numbers do equal each other. Now, in this case, you actually can find a common base. Even though these numbers are not the same, there is a number that can be raised to create a 4 and an 8. I can actually raise 2 to something that makes it 4, and I also can raise 2 to something to make it equal 8. So 2 squared is going to give me 4, and 2 to the third is going to give me 8. And we now have bases that are the same, so we can now take our exponents. So we will have 2 times 5x, and we'll have 3 times 2x plus 7. So we have 10x equals 6x plus, not 7, 6x plus 21. Subtract 6x and we'll get 4x equals 21. And so we'll get x equals 21 divided by 4. So we can continue to find common bases. We can come up with a number that can create a 32 and a 2, which 2 is a prime number, so we know that 2 must be the base. So 2 raised to something is going to give me 2 raised to the x plus 5. 2 to the 4th is 16, so 2 to the 5th power is 32. So now we can take the exponents and set them equal to each other. So we'll get 5x plus 25 equals x plus 5. So we subtract, we'll get 4x on the left, and we'll get negative 20 on the right, and so x equals a negative 5. Now, there's going to be certain instances to where you cannot have a negative value for x when you're doing log and natural log. But in this case, since we're just dealing with exponents, you can have a negative number. Now, in this case, 27 and 9, well, they're common. A common factor that goes into both of them would be 3. So I can make the 27 become 3 cubed, and I can make 9 become 3 squared. And now I have bases are the same, so I can take the exponents and set them equal to each other. So I'll get 3x minus 12 equals 2x minus 6. So I will subtract 2x on both sides, and then I'll add 12 on both sides, and x equals 6. Same thing here, 125 and 625 actually have a 5 in common. 5 can be raised to something to get both of these numbers. 5 to the 3rd power will give me 125, and then 5 to the 4th power will give me 625. So now that we have common bases, we can set the exponents equal to each other. 4 times negative 3 is negative 12. So I'll get 9x minus 12. So x in this case will actually equal 0. Solving using inverses. So in order to solve for e to the 2x, we cannot touch that at the moment. We first need to get rid of everything else on the side. So I'm going to subtract 7. So I'll get e to the 2x equals 73. Now we have x in the exponent. Therefore, we are going to have to use the inverse to get it out. So we will have to use a natural log. So I'm going to rewrite this as a natural log. So the natural log of 73 equals 2x. Think about it in the case that This is an understood e as a base. E raised to the 2x, which it is, equals 73. So that is correct. We did actually write the inverse correctly. So now you can take this natural log of 73, and then we're going to divide both sides by 2. And in your calculator, you actually can go ahead and just solve that. So in your calculator, you can go ahead and solve that, and you will get 2.145 in your calculator. The next, before we can mess with this e to the x, we first need to get rid of the 5. So I'm going to divide both sides by 5. Then I'll get e to the x equals 12. And now I can rewrite this as a natural log to get the x out of the exponent. So the natural log of 12 should equal x. And if you put that in the calculator, you will get e to the 12. You will get you will get 162,754.79. Next, to get x to be out of the trap of the natural log, we are going to do the inverse. So this is a e raised to the 20, and that equals x. So x equals 48516519554. Now, we cannot find a common base between 4 and 50. It does not work. 2 squared gives me 4, but I can't raise 2 to something to give me 50. So we're going to have to rewrite this using a log. The reason we do not use a natural log is because we do not have e. So in this case, we're going to use a log to rewrite this. So it's going to be log base 4 of 50 equals what the exponent was. The exponent always goes out on the outside. So now log base 50 of 4 is 2.8219, and so to solve, we're going to subtract 1 to get 1.8219. And now we're going to divide both sides by 2, and we should get 0.91096. Now, obviously, we do not need that many decimals, so depending on what the directions call for to rounding, you would obviously round it to that number. Next, you have a natural log. Remember, the natural log is represented by a base of e, so we're going to go e to the second power equals x plus 1, also to the second power. So technically, if I take the square root of both sides, I will get e equals x plus 1. So e represents 2.71828. So if I subtract 1, I should get 1.71828 as my final answer. In this case, the x is trapped inside of a log, so we need to get it out by doing the inverse. So I'm going to rewrite this as x plus 2 raised to the 2, and that equals 9. Okay, so we have a function that is squared, so I need to do the opposite and take the square root of both sides, and I'll get x plus 2 equals 3 and negative 3. If we subtract 2, we'll get x equals 1, but when we subtract 2 here, we will get negative 5. If you plug negative 5 back into the original function, you would have the log that has a negative base, which is not allowed, so your answer is only x equals 1. We can use log properties and also how to solve them. When we have two logs that are added together, we can actually bring them into one log that's multiplied together. This 2 was an exponent, and then I can rewrite this log. So 2 raised to the third equals 9 times x times 64. So we'll get 8 equals 9 times 64, which is 576 times x, and then solve for x. I'm going to divide by 576, and I will get 1 over 27. In this case, I can do the same thing. Since I have two logs that are divided, then subtracted, then I can actually make them 1 and divide them. So this would be 3 raised to the 0 equals 8x over 16. Now 3 to the 0 is the number 1, and 8 over 16 reduces to a half. So to solve for x, we would multiply both sides by 2, so therefore x will equal 2. In this case, we have the natural log of x divided by x minus 1 equals 1. To get rid of the natural log, we would use the letter e, so the e raised to the 1 is going to equal x divided by x minus 1. So anytime you have a fraction, you can make everything a fraction, and then you can cross multiply. So e, I'm just going to rewrite as 2.718. So e times x minus 1 equals 1 times x. So we'll get 2.718x minus 2.718 equals x. So we'll subtract 2.718 on both sides, and we'll get a negative 1.718 times x, divide by that, and x should equal 0.6313 for your answer. Solving properties, continuing, anytime you have two logs added, that means you can multiply the logs together. And once you do that, anytime you have a log of a function on one side and a log of a function on the other side, you can cancel the logs, leaving you x times x squared minus 8 equals 8x. Now here's the deal. You cannot do this. That is not allowed. You cannot cancel logs all across. It can only be one log on the left and one log on the right. So you first need to condense this to one log before you're allowed to cancel the logs. So you will have x cubed minus 8x equals 8x. So you would subtract 8x to get negative 16x equals 0. So you can factor out an x, and you're left with x squared minus 16. So you would have x times x minus 4 times x plus 4. And so therefore x can equal 0, x can equal 4, x can equal negative 4. However, if you plug 0 back in, you cannot take log of a 0. That is not allowed. If you actually typed in log of 0 in your calculator, you will get an error. You also cannot have a negative. If you plug in negative 4, you have log of a negative number, which means that is also not allowed. So your only answer in this case is 4. Not all three, only the answer x equals 4. Next one, you have natural log of, you can condense the left-hand side to say natural log of x plus 1 over x plus 6, and that equals the natural log of x squared. Now that you have one natural log on the left and one natural log on the right, you may cancel the natural logs, leaving you x plus 1 over x plus 6 equals x squared. Make everything a fraction and you can cross multiply. So you'll get x squared times x plus 6 equals x plus 1. So you will get x cubed plus 6x squared equals x plus 1. So you'll get x cubed plus 6x squared minus x minus 1 equals 0. And from this point, you can either use synthetic division or you can use a graphing calculator and find out where it crosses the x-axis. Now, according to synthetic division, you do not find a rational number that does work in order to give you a remainder of 0. So if you were to graph this function, you would see that it crosses the x-axis at x equals 0.47, and that would be your answer. Please remember also, the log of a number minus log of a number equal to log of a number. You cannot just cancel out the logs. You first have to condense the logs. Subtraction means you can divide those functions, equal to log of 2x plus 3. Now you may cancel the logs to give you something that you can solve, but please do not cancel the logs until they are condensed into one log on the left and one log on the right.